Okay, welcome to the College of Design, Construction, and Planning Research Seminar Series. It's the 2021 seminar series that spills into the spring semester. I am Meg Portillo, Associate Dean of Research for the College of Design, Construction, and Planning. So glad you're here to spend the next hour with us. It is my delight to introduce Dr. Karla Saldaña Ochoa, who is finishing her first year on the University of Florida faculty. Her academic home is in the School of Architecture, and she is one of the 100 AI faculty that are really positioned to transform the university. Some of you may know Dr. Saldaña Ochoa and know that she is an Ecuadorian architect by training, has not only completed advanced studies in architecture, but also holds a master's in landscape architecture from ETH Zurich. And she also has earned her doctorate at ETH Zurich, which focused on the integration of artificial and human intelligence, particularly focused on developing a better understanding and response strategy for natural disasters that plague us around the world. So since she joined us last August in the School of Architecture, she's really been focusing her research as well as her teaching on the interplay of artificial and human intelligence at the building and urban scale. She's also launched the Sharelab, which she may mention today. We're very excited to hear what she's been doing. And again, it's an absolute pleasure to hear from Karla. She'll be presenting her work, and we will block out some time for questions or comments. You can pop those into the chat, or you can unmute yourself and ask questions toward the end of this session. Thank you, Karla. The floor is yours.
Thank you, Meg, for this kind introduction. I think I will just go ahead and share my screen so we can start with the presentation already. So I hope I managed. I did the last time. I was successful a minute ago to share my screen. So I hope now you're seeing my slides. Perfect. So as Meg said, I'm Karla Saldaña Ochoa. I'm an assistant professor at the School of Architecture, and I'm the lead researcher at Sharelab. And today, what I'm gonna talk about is the interplay between human and artificial intelligence in architecture. So I usually like to start with 3 facts that I find interesting to speak before I introduce artificial intelligence. So the first fact is that we're living in an urban planet. So we are experiencing an unprecedented urbanization of our planet with 7.8 billion people, and half of those living in urban areas. In 2016, the United Nations declared that we're living in an urban age because more than half of the world's population lives in cities. The second is that the spread of ubiquitous computing and urban data streams. So for the next year, the total number of mobile subscriptions will match the global population. So information technology is 30% less expensive each year, and it doubles its installation every 18 months. And the third is, if we look back at the history of computation, we see that we've gone in a wild movement of decentralization from monofunctional machines to a world of applications. We have gone from one computer, many people in 1943 to one person, one computer in 1970, and today we reach the radical inversion of one person, many devices in 2021. So, and this second movement in 1970 changed the mechanic point of view inherited from the Industrial Revolution to a networked one. With such vector, the internet was created, which collapsed both the ability to communicate and the capacity to record knowledge through time, allowing us to have a video call in real time with anybody on the other side of the world. So now we can be in any place and at any time. It also changes the established architectural practices from one that is limited with limited resources to another one that can access this plenty of information to enrich its work. So hence, we can invite questioning how architecture will be influenced by these many AI algorithms developed to ease many of the tasks that we have today. So this is my question: what will happen in 2050 with what we know now? So to try answering this question, we can look at one source of tracing news and trends, which is Twitter in this case. And if we search about AI and design, we see this group of posts that are like the ones we're having on screen now. And what you will identify is a trend called AI art, and meaning that all of what you're seeing now have been automatically generated from this enormous amount of data using artificial intelligence algorithms. So if we go back to the beginning of the use of the word artificial intelligence, we'll see that the first person to use it was Alan Turing, and it's almost 70 years ago. So he proposed that a machine act intelligently when it could trick people into thinking it was human. For this, for proving that, he proposed an exercise called the Turing test. So he used a question and answer test to prove his point. The question and answer test involves three actors, so it has a human A and a human B, and it has an interrogator. The purpose of the test is for the interrogator to determine who is who, depending on the answers. This is when Turing wonders what happens if a machine takes the position of A. If A is then wrongly assumed to be a human, then such machine has passed the test. If we abstract Turing's question and answer test into a mathematical function, such function can be plotted into a Cartesian plane, where x-axis represents the question and y-axis the answers. On the left is a collection of points representing the interaction between the interrogator and a human. On the right-hand side, we find that what the machine tries to do, which is to learn this interaction by finding a function, or in this case, a curve that satisfies all the points. And in the process, it predicts the answers when interpolating between points. It is really important to point out that Turing did not assume such a machine is sufficient to perform all activities that require human effort. So this A machine or AI, Turing did not assume that we'll be able to perform all the activities. In his PhD thesis, he published before this article on universal machines or AI, he introduced the notion of an O machine, or what he called an oracle. So Turing's description of all machines considers artificial intelligence and human intelligence jointly. If we look at the universal machine or AI, it has a fixed process that cannot be interrupted until it's finished. But an O machine, as it is a combination of artificial intelligence and human intelligence, can adapt and evolve depending on the circumstances. Moreover, an O machine can deal with questions that have moral and ethical concerns, where both reason and computational power should be used together. So here is a brief introduction of what artificial intelligence is. So artificial intelligence has these twofold approaches. So the first goes towards reducing human intelligence to a symbolic manipulation, and the second that goes towards the simulation of neurological behavior. So the first on the left involves rule-based systems such as decision trees and is based on logic. The second on the right investigates the creation of artificial neural networks. And around 1960, the symbolic method achieved a great success, and the neural network approach was abandoned. But the situation changed in around 1980s when symbolic or logic-based approaches reached a bottleneck, and at the same time, computational power grew, allowing computers to control a larger number of parameters. So the neural network method was taken up again. So this branch has two approaches as well. So one that seeks to explain or understand intelligence, and another that observes data patterns and conducts automatic learning. So the last one is the most used today, and it's based on probabilities. In 1995, Stuart Russell and Peter Norvig from Google wrote a book called Artificial Intelligence: A Modern Approach. And they broke artificial intelligence into 5 distinct research areas to conduct the Turing test, which are machine learning, expert systems, computer vision, natural language processing, robotics, and generation. And these areas use artificial intelligence algorithms as a problem-solving tool to solve specific problems within the research area. However, from my point of view, or from the Sharelab point of view, nowadays, instead of solving problems with AI, we are solving them. With the current abundance of AI algorithms and big data, everything becomes available, and therefore it also becomes solvable. Hence, what matters the most is to formulate the right question to be addressed. Just to give you some numbers, in 2002, humanity created 2 exabytes of data. Today, we've reached a total of 44 zettabytes of data, and these data are produced by individuals either intentionally through blogs, social networks, and discussion forums, or unintentionally through online and offline interactions while working, shopping, or traveling. So every movement we make on the web leaves these digital footprints, which then creates what we know as big data. So big data is noisy, it's messy, and we have a lot of it. But what we have to take into account is that this big digital data can be transformed into numbers by artificial intelligence algorithms. And such numbers encapsulate the complexity of each data point. So those numbers mean nothing to us humans, but they do to machine or artificial intelligence. They are the ones who use them to perform mathematical operations or statistical operations and to actually react to that enormous amount of data. And these numbers allow them to have a rational response to this data because these numbers are their language. So thanks to artificial intelligence, we can make sense of this enormous amount of data. And we know now that AI has a large computational power. It is fast at solving mechanical tasks. And the interesting thing is that these capabilities are increasing all the time. So I propose that we should evolve as well and implement our work using that. To return to this slide that I showed at the beginning, so we can assume that researchers can take advantage of the abundance of artificial intelligence algorithms and databases to create this complex, specific generation, predictions, or classification without designing or training the algorithms from the beginning. So now, in academia, we can effectively encode spectral and spatial information based on data itself, allowing us to use this information to initiate an architectural or urban design process. I think if we do that, we can take the advantage and use an algorithm to machine generate various design solutions from the learning of the big data, or to explore the vast space of possible design solutions for the specific design brief, focusing on questions that require human creativity rather than machine productivity. So therefore, given the fact that such technologies are shaping the way we live and significantly shaping the way we work, I think we should ask the following questions. How can we include such technologies in a design workflow while preserving our role as creative entities? So the images that you just show, that I'm showing to you and that you're seeing now, are compilations of today's posts on AI and design. I think in order to answer the question that I just posed to you, we could not consider architecture as a reduction. We shouldn't consider architecture only as a creation of data, which is what we're seeing here. So all of the artists that are creating this art in AI, they are curators of data. So they produce a number of results, and then they go through and parse through and find the one that is more appealing, and then they post it. So I think architecture is not only about curation, but it has extra layers of information that we learn through the career, which are related with the cultural background, with the user needs, with the sensitivity of certain formal qualities and, for example, sustainability. So I think all of those layers should come above and not only be reduced to creation of data, but should also bring more information to a design process. And now I'm talking about images, but there is not only generated images around. In the recent years, we've seen various books published using AI algorithms as co-authors. So data has come, it comes from various outputs. So we have image data, we have text data, we have numerical data, and they can be used to generate anything. So what you're seeing here is just a compilation of these books that have been generated by AI. I just happened to finish one of the books that is here, and you can still identify the lack of creativity in generation when you read this book. But then it comes to the conclusion, like if we can consider all the information or all the text or images generated from the last 500 years, we can understand that these data are within this normally distributed curve that we're seeing here. So that's the examples that we're having today are just the interpolation between these collection of data from the past, but it's constrained within that. So then there is another question about how we're actually generating new things from historical data, because they are being generated through these, let's say, the normally distributed data that is within this curve. But my question is, what is happening on the edges, right? Because on the edges, I think there is where it lies this idea of masterpieces, those pieces that cannot be labeled as commonality among the whole data that we have created. And I think the edges are carrying a lot of information that is really relevant for us today. And I think to talk about these a little bit more, here I have, I'm showing you one example that studied paintings throughout time to create a rating of creativity that consider its originality compared to previous work and the value of how valuable it is or influential for future work. And what is interesting to identify in this graph is that different pieces of art that are considered masterpieces were always far from normally distributed data. So here, the question that I posed about how can we produce a creative work, how can we really produce something that relies on creativity, which is a huge part into an architectural process, it is still present now when we use artificial intelligence. I think artificial intelligence or the big data that I told you at the beginning, they are really helpful for us to understand the commonality of the data that has been generated from the past. So we can build beyond or build upon that, and we can create something that can be considered that relies in creativity solely. So I think it's interesting also to look at how I think AI is successfully being implemented into resolving some architectural problems that were considered architectural problems at the time. So what you're seeing here are a screenshot of Ryan, which is a AI powered tool to automatically generate layouts for offices. So I think here we are getting into a position where we can use this artificial intelligence to resolve some of the problems that we were looking at before and required a lot of time to figure it out. But now we can learn from data and we can propose that as a way of optimizing space. So not only office space can be designed in this way, but we can also think as parking lots, for example, or the distribution of lots regarding the passive energy into a plot. So I think this is interesting to look at. How can we ease the work that we're doing in offices now, but still think of how can we use artificial intelligence as a creativity tool, like to empower creativity. And I think to return to this idea of the distribution of data, if we want to approximate the details of the distribution, I propose to think of AI as being able to point to a particular direction but we are the ones who decide whether that direction is good or bad. We are the expert knowledge, and we know all of this complexity or these complex data or layers that should come above the formal characteristics of the thing or of the project that we're developing. So in the future, we should take advantage of the state-of-the-art technologies to create new processes that can emerge through a close collaboration between human and artificial intelligence. The idea is that technologies are used to augment human capacities and not only the physical, but also the intellectual capacities. When architects are faced with tasks such as planning, design, and construction processes, they could concentrate on the creativity part of the job rather than waste time in solving problems that machines can quickly solve. So artificial intelligence excels at solving problems with clear answers, processing data, and performing repetitive tasks, thus freeing up time for architects to be creative and to work on more open questions that require reasoning and creativity. So if we go back to this image that I showed you at the beginning, like what is going to happen in the future? So we are now building what we're building today will create that the future is urban, right? So hence we have to concentrate on constructing better with better design processes that yields better geometry and better construction materials. And we should use AI to help us arrive there in defining tasks that require that computational power, and we should be the entities that require that are inputting the creativity. I think we should lead research that focuses on human-centered design. My guess is that in the future, the world will be full of clusters of knowledge. Everyone will like to be connected like today, but will like to decide with whom to be associated with. So we will use AI to create these personal Googles or these personal clusters of knowledge. And the thing is that here, human-centered design should be at the core of each AI application. We should always think of what's the shared responsibility between humans and artificial intelligence. And this leads to our motivation at Sharelab. So we are a group of researchers that wanted to reflect on the shared responsibilities between human and artificial intelligence. In each research question, we always first ask whether it makes sense to bring AI to play. And if the question is yes, how? What is the process that we have to create in order to have this shared relationship between human and artificial intelligence and to conduct a research that is human-centered in AI? So what I wanted to share with you today was, of course, our, let's say, introduction to Sharelab and what we are thinking about human artificial intelligence in architecture, what is big data for us, how should we go beyond this idea of the normal distributed data. So I'm going to show you three projects and four projects. And here we have they are divided into research and into teaching. So in research, I'd like to share with you our motivation of how we conduct research at Sharelab. So we always, as I said, think that it's the most important thing to have is the right question, which is the hardest of all. So first we start with a question, and then if the question involves using artificial intelligence, we have a process that has 3 steps, which is for every automatic learning, you have 3 steps, which requires the teaching that deals with the data in any way, like whether it's labeling the data or whether it's extracting features from the data for an unsupervised learning. Then we go into the learning, which deals with the algorithm itself. So the algorithm here, we're thinking what will be the best architecture to work with the teaching or with the data. And then we have the third step, and in this case, it's inference, is about the validation. So what we think it's the important part in all of these 3 or 4 steps that I'm showing you now is that the human should be able to segment the process and always give a feedback loop in each of them. So throughout the last 5 years, I portray an interplay between artificial and human intelligence to address either urban or built environment design processes. So here are just an overview of some of the projects we've done. So we have projects at urban scale and we have projects at building scale. So if we're going to look at projects at urban scale, I'm not going to talk about all of them. I will only focus on one specifically, which I like to share. This is one project that we did in collaboration with my colleague that is now joining the Sharelab as a visiting researcher. His name is Guo, and this is one. Pardon me, quickly. I need to do something before that. All right. I'm coming. All right, so here it is. So this is a project that we call a framework to assess food security for the management of agricultural resources with automated aerial imagery detection. So as I said, we always start with the question. So the question that we had at the time was, can urban characteristics be automatically obtained to inform decisions in urban context? So this answered this question. We propose an approach that fulfills the necessity of a rapid food security, assessment and planning, exploitation and management of agricultural resources, specifically in urban areas. So the pipeline had an automatic localization and classification of food type trees and a segmentation of roads using high resolution aerial imagery. So here we used two supervised deep convolutional neural networks. So the first was to localize and classify trees, and the second to mask the streets from the aerial imagery for transportation purposes. So additionally, we propose density maps, which allow to comprehend the site quickly, and ultimately we introduce a method to optimize the harvesting of those fruits. So here you can set specific scenarios such as the maximum time for the collection, the path length, and the location of warehouses or security points, etc. So what we learn in this project is that we can actually, what I said in the question, like how can we automatically obtain information from this database, from this data type to make decisions in urban contexts? And this led to thinking, how can we use this technology from segmenting images from satellite, segmenting objects to satellite imagery and setting optimization solutions and to resolve certain questions. So how we see these being applied, and I will show you at the end how we're applying to here. So we are thinking of using automatic urban data collection score in the case of campus vulnerability to disasters, in the case of walkability analysis, or creating urban databases. So these projects that I'm mentioning out loud are projects that we're currently conducting in the lab. And if you would like to know more about them, you can visit at the end. I'm gonna have the link to our website. And if you're interested in collaborating with us, we're also happy to welcome you to Sharelab. Another project that I'm gonna talk today is about, it's on the building scale. So this is also a project in collaboration. So what we did here, I have to wait a second. I have to apologize because, as I said, I wanted to have a conversational approach, and then I'm showing you things that are not supposed to be there. All right, so this project is called Beyond Topologies and Beyond Optimization. So the question that we were trying to address here was, can machine and human intelligence work in collaboration to address a design task? So in order to answer this question, we went back to 2006 Rivka Oxman publication that is called Theory and Design in the First Digital Age. This publication described the evolution of design processes from a paper-based model used for representation to a computer interface that replaced the paper, but is still a representation tool, and then to use the computer to perform the task of simulation. So Oxman ended with today's scheme for design processes, that is an iterative workflow, which consists of a predefined cycle of generation, evaluation, representation, and performance. In this work, we derived from Oxman's scheme and propose a cyclical process that joins the machine with the human capabilities to create this framework to generate design options. So what you're seeing here in this diagram, we have these operations that were described in Oxman, but we have linked them as in a loop. And also we have set the human in the center that can actually iteratively select which operations to conduct without needing to have a linear sequence of operations to actually generate a result. So here, what you're going to see are some of the trials of users using this methodology. And I'm going to show you which are the algorithms used for each operation, because we wanted to make sure that in each operation we had the human involved for the next step. So we have 5 operations. So in the generation, we use an algorithm called Combinatorial equilibrium modeling. And this is a method for the design of spatial networks in equilibrium that is based on the graphic statics and the combinatorial state between tension and compression. For the quantitative evaluation and filtering, we set some objective functions to ensure a structural performance. And here we use them as soft and hard constraints to filter the design options. We have the representation and clustering. Here we use higher order statistics to encode the features of the design options, and self-organizing maps, which is an unsupervised machine learning algorithm for clustering. For the qualitative evaluation and selection, we developed an interface that will allow a user to select the forms depending on their preference. So here we are creating a training data while the user is interacting with the interface. And this training data is setting forms that are preferred and forms that are not preferred. So then it feds into a machine learning algorithm that will learn the preference of the users and will be able to regenerate structural forms that are within the preference of the users. And then we use again the algorithm of combinatorial equilibrium. So this process relies on this series of operations that are generation, clustering, evaluation, selection, and regeneration. And it allows to create multiple design options. And also it allows to understand the design space according to an objective and subjective criteria that is defined by the human designer. So through this interaction between the human and the machine can learn the nonlinear correlation between the design inputs and the design outputs preferred by the human designer and generate new options by itself. So in addition, the machine can provide insights into structural performance of the generated structural forms, meaning that you're not plainly looking at the formal characteristics of the form that it's been generated, but you're able to analyze the structural performance of that form. So your decision on the selection of the final set and the final form, it's not only formal, but it also contains a lot of information that will be important to make the decision. So as I told you at the beginning, this methodology was applied by different researchers or by different users, and I'm going to show you some of the different ways of how designers have used this methodology to generate different design solutions. So here, for example, you see in the center of the slide, you have a list of operations that can be selected depending on how you wanted to see or how you wanted to generate these forms. And then on the left side, you see the path or the, let's say, of the footprint of how the human actually selected all of these states. And on the right side are the outputs of this interaction. So per different footprint, you get different parametric settings, and then you get different design solutions. And the interesting thing here is that you're not constraining the designer to follow a path, you're letting it design the path itself, like the parametric or like the generation settings as well. So it is free to select however it likes to, he or she likes to do it. And then the output is always going to be different depending on what you design. What are the objective and subjective criteria for this generation itself, and how we're bridging from this project to today. So now we're focusing on creating an automatic structural form generation from the scripted text. So you can imagine that this process that we did in order to regenerate the forms based on the preference of the designer can be questioned, as it brings the reason why you are having a binary decision making into something that is more complex. So here we're adding a complexity within the description of a project. So we are training a natural language processing algorithm in order to encode jury commentary from winning competitions of architectural projects in order to find what is the discourse used to describe architectural pieces and link that discourse to the form itself. So now when you want to generate something, you won't have to go into the process of selecting and creating a training data of prefer and not prefer, but you're going to be able to write about what you're wanting to design. And then this generative algorithm is going to bring a solution based on the terms you're using. And then the interactive, it's going to be embedded into this interactive process where you're going to be able to always redefine or reselect the way you're expressing the design solution to be. So this is a project that I've done individually, and I wanted to discuss with you one project, which it's going to be the last one, but I'm going to have to skip a little bit from this because I think we don't have enough time. All right. All right, so this is one project that I think it's interesting to talk about, and this is a project that I developed in my PhD that I called Artificial Intelligence for Housing and Shelter Needs. And here we were addressing the operation that deals with shelter and housing reconstruction and construction after natural disasters. And the question I asked here was, how can we create a decision-making model from multimodal natural disaster data that is tailored to the housing sector? So one of the key challenges in disaster is combining the plethora of available data ranging from social media data to satellite imagery and turning it into a concrete and actionable insight. This is especially true for humanitarian housing and shelter needs, because such operation deals with spatial and constructive constraints that, if not considered, can fail to achieve adequate solutions. Therefore, the objective of this experiment was to create an instrument that can guide the responses of decision makers at the operational level to address operations in the shelter and housing sector. So for this experiment, I use 3 types of data. So I use disaster characteristics data, location-based risk data, and spatial conditions data. And to ensure the scalability and the low cost of this approach, I only use open and online data. So for location-based risk, I included the World Bank's Global Urban Risk Index, the European Commission Informed Index, UN data, and for climatic conditions, I added the sea temperature conditions at the time of the disaster. To capture the spatial conditions, I use satellite imagery from Google Maps. And since all of this data was collected by each disaster, and it comes from so many sources, their modality is equally diverse. So I needed to deal with this multimodality of data, and I applied a fusion approach at the decision level that allows me to use all of these features from this multimodality data to create a vector for each natural disaster. And then what you're seeing here is per natural disaster, you have 19 layers of information that is describing the disaster itself. So after that, I fed these vectors describing each natural disaster into an unsupervised clustering algorithm that in this case is, I use self-organizing maps. So what you're seeing here is each natural disaster is positioned according to a similarity of its numerical vector concerning all the neighbors around. So what is really interesting with self-organizing map is that you can further visualize how each feature that is describing a natural disaster provides a detailed exploration. So in this way, it's possible to identify which features influence a prediction the most, and then you can actually select the ones that you want to work further. So how this has to do with housing and shelter needs, so you're going to see it now. Now I brought some natural disasters that happened after 2020 as a validation method. So here, each natural disaster is positioned into this grid, and then it looks at the most representative case of this cell with this position, and then it uses that information to extract valuable information that will be relevant for that specific event. So here, for example, we have the data from the shelter. This is from the shelter emergency shelter information from the global shelter cluster from the UN. And here they give you information about the things they found important when the disaster strikes. So this is valuable information that is helpful for new disasters if they are able to look at this after natural disaster happened. So here I was able to correlate consequences about total deaths, total affected, and total damages. And then the recommendations that I got from the new disaster, they are derived from this shelter cluster about what are the strengths that they should potentiate and what are the weaknesses. So I return to this process that I explained at the beginning. Each of the projects showed this interaction between the question that we have and then how each of these steps were done by including the human on collecting the data, curating the data, setting the labels if it wasn't supervised learning, and then using an AI algorithm to perform the automatic learning. And then at the end, it's really important to have a validation process where we actually look at what is the output of this algorithm and then set a feedback loop into the teaching again if it is necessary. So I don't know how much time we have left, but I can show you quickly one of the experiments we do at teaching. I think we have some time. All right, great. So I think this is going to be fun because this is some of the work I've done with students at ETH and students here at UF. And the focus on these courses was most about using AI as a tool for productivity rather than optimization. So we are using it as a way of showing us a path or a vector, and us deciding where should we go. So here's an overview of the courses I've taught in the last year. So I have been teaching AI in architecture since 2017. And recently in 2021, I was able to conduct a design studio that relied on artificial intelligence, which is the one on the right. So I'm going to talk about a course that happened in 2019 that had 3 iterations that was called Map and Models. And this course I co-teach with Geosurveillance, which you will find him in our website. That is currently the visiting researcher in our lab. So we always have an interaction between theory and practice. So each lecture was divided into giving input about what we're going to talk in the sense of data, algorithms, and concepts. And then we were applying in practice a coding exercise that will visualize exactly what we meant with the concepts we introduced. So here, the students work with the database, which is challenging to work, but it's very interesting as well to work. The database was social media. And then they use the tools that I showed you briefly about how to organize data through an unsupervised clustering algorithm to address questions about urban phenomena. So here is just an overview of the different projects they developed. So they were asked to create kind of a poster or a statement about what they want to talk. In the case of some students, they wanted to talk about the perception of nature, how nature is perceived through time and space. We also conducted this course when COVID struck, so students were interested about what are the things that we're talking about COVID today. Another student wanted to talk about what is the, if there is any relationship between a portrait in the Renaissance and what a selfie is today. And they did it through data. So all of the questions that they have, and we stress this from the beginning, that's the most important thing of the project. You have to come up with a question that you're inspired to work with, and then we will find a way of solving your problem. So here's, for example, one of the projects that worked at the time with when COVID struck. So the students collected thousands of posts around the world about COVID, and their findings was really interesting because they could see how much scientific research was published and how much interior images from inside the house was published, and what was the difference if you could plot them about the meaning of the post, how different they are, like what people were experiencing in their house and what scientists were telling us was just these two clusters that you see in here. Another project was what they called this user geosurveillance. So they wanted to map a city before and after COVID, and they wanted to see the places that got populated and the places that got that were not having users. So then they identify without even telling the algorithm what is business areas or housing areas, but by only knowing how the users were interacting or were staying at home, they were able to map this out. Another project like this, I talked very briefly about this portrait to selfie. So they collected, using keywords about selfie and Renaissance, images that could be related to find these references between the portrait and the selfie. So these projects are playful. They are not scientific per se, but they are playful, and they are working with a question that is really interesting to dig in. And students that join our course, they didn't had any coding skills before, but they at the end were able to understand what is required to work with data. How can we actually crawl data from the web, and how can we apply algorithms in order to answer questions that we have. And I want to talk about this course that I taught here at UF, which is called Fluid on Water and Land. And this is a design studio that is dealing with landscape architecture. So here I also divided the class in different modules. And in each module, we had an introduction of concepts, and the students were able to, from the beginning, were introduced to AI, but not as a way of optimization, but as a way of searching space. So we use different data sources. So in this case, we use point cloud data, and the project was on the site here in Gainesville that is called Devil's in Copper. So we collected the data through terrestrial laser scanning, and here is just a snapshot of the point cloud model. And here, what is interesting to working with this data source is that the students were able to work directly on the site. They didn't need the necessity to measure every single step of the staircases that you're seeing, but we had that already in our computers to work in the beginning. And one interesting thing that just happened is at the end of 2021 or middle of 2021 is that the students now have access to cell phones that have a LiDAR embed or included. So part of this model was, of course, we gathered together with Suji and Kim, colleague that collaborated with us in this project, but we also had the students on site with their phones collecting data. So they learn how to collect, they learn how to segment, how to merge the data, so to have a more robust site. But we also work with social media data. And this is something really interesting to point out, because usually we are active users of social media, but we don't use it as much to influence how we react to certain phenomena. So what we did in this case, we went, of course, inside. We started collecting this data with our phones, but we also were questioning what are the things that we want to potentiate on this site. What are the keywords or concepts that are popping up to our minds when going on the site? So then I asked the students to write down those keywords, and then we went online and we started getting what are the users' keywords, how are they describing the site. So we end up with this list of words that you see on the screen that are telling not only about the users, but are telling about the intentions that we as architects have for this place to be. So with this list of keywords, we started collecting social media data, and then each student in their own tiny computer collected more than 4,000 images to work with. So they selected from that huge list that you saw, each of the students selected some keywords that you're seeing here on the screen. And then from that, they started the process using artificial intelligence to organize these number of data that was more than 4,000 per student. So then they were able to organize the posts from social media in these grids that you're seeing. Each grid represents a student. So they were able to use AI to encode the text from social media and organize it in a way that is grouping similar posts in one cell, and then all the neighborhoods or the neighbors around are similar to the one and it creates a spectrum of similarity. But they didn't only work with the text data of the post, they also worked with the images on the post. And the interesting thing here is that through AI, we were able to analyze these images by different lenses. So we could organize the images by the colors on the images, by the structure, formal structure of the picture, or by the objects within the images. So here the students had the freedom to choose from which method they would like to organize the image data. And here, since each of them had a specific grid of images, so each grid, even if we're seeing, let's say 100 images here per grid, each grid contained more than 4,000 images that they worked with. So the next step was to look around, what is our database? So this is more or less of understanding what we have collected, and then select the images that are more appealing to the concepts that we defined at the beginning for this proposal, that are reacting to the user's needs and to the intentions that we have. So after they started selecting some of the images, I invite them to create something that I call an atmospheric image. So an atmospheric image is something that is conveying the feeling of the place. So here they use these images from social media and they created these beautiful collages of what they're wanting to create on site. What is their feeling? If they have to create something, they first have to imagine it abstractly, then we can materialize it into a space later. So after they started imagining how the place should feel, what their intervention should look like when they actually realized it, we went back into the point cloud model, and they started creating the space and reflecting how the point cloud model can be segmented, so it actually recreates what are their feelings through these atmospheric images. So we use a mixed method between analog tools such as drafting on top of the model, and then we also work with Rhino and Cloud Compare models. And the whole idea here is that the students weren't using only one software, but they were embraced to use many in order to create their projects. So we did not only stay in the digital, as you're seeing here, but we also went into physical. So because the point cloud model is as precise as the site itself, we were able to create a physical model from that. So we created which I think you can see on my back. So from the point cloud model, we use digital fabrication techniques to CNC the terrain. And then these sticks that you're seeing are the position of the trees on the site exactly. So each stick is a tree on site. And then the students were able to 3D print their projects on site. And not only there, but then we used another software that helped us visualize their projects, which is a game engine and a program that supports point out. So here the students could actually navigate interactively their project rather than only having a fixation or of a model. But they had a 3D printed model, they had a game engine interface to look at their models in the point clouds. They had the atmospheric images that use AI, and then they work in this collaborative environment where they can use all of these tools to create a project at the end. So with this, I wanted to point out some future steps that I see Sharelab could roll. So these are some of the projects I'm currently working on. So I am working on a project that is for airport cooperation for humanitarian assistance, similar to the work that I show you with natural disasters, but this is specifically for infrastructure. I'm working on a project about from text to 3D forms, which deals with how can we generate a structural form through a descriptive text. I'm working on a project that deals with walkability, and specifically for school routes and walkability, and how can we use AI to automatically identify urban objects or urban characteristics that can describe a walkability index. And then another project that is really close to my heart, and this is how to encode spatial features to understand and improve infectious disease needs. And here we're partnering with Emory University, and we're trying to find how can we serve best HIV patients and make the neighborhoods ready for them to react to the need. This is on the let's say research side, but on the teaching side, on 2022, this summer, we are organizing a workshop and a conference about what we call playing models, which deals with the implementation of artificial intelligence and storytelling techniques such as AR, VR, and all the extended realities tools for architecture. And then we are inviting, so this is a summer course. We have students from Sharelab Orlando and main campus Gainesville engaged in this program that has 4 modules that are going to deal with artificial intelligence, game engines, and VR techniques. And we are going to, at the end of the workshop, we're organizing an international conference, invited speakers around the world that are going to describe their project and how they use the same techniques, and are going to be juries of the students' work that we have conducted in June, which is the workshop. So the conference is happening June 10, 11, 2022, and then I'm inviting all of you if you want to attend. It's going to be in Orlando, but we're going to have an online streaming as well if you want to attend. Yes, so I think I am on time, so I can get some questions from you. Thank you all. I know I just share a lot of information with you. I just wanted to show you the spectrum of possibilities of research branch that we have at Sharelab. So I encourage you to visit our website or contact me directly if you want to work with us, or if you have any question about the projects I'll share with you.
All right. Thank you so much, Karla. It would be interesting to hear from the audience. Do you have any comments or questions?
I see some questions on
the chat coming up.
Do students need to have some prerequisite coding or programming knowledge to take any of this courses? So they don't need to have any coding expertise. They will need to be motivated to learn, and that's something that I understood when I was teaching the design studio. So if you find this interesting, you will get it immediately. But if you're fighting against it, it will take you long to get into it.
I'm curious, Karla, how have you can you share ways that you've connected with some other AI researchers, in the college or beyond the college, and how has that influenced your approach?
Yeah, so I'm currently collaborating with researchers in the College of Business here at the UF. I'm collaborating with College of Education at the UF as well. Here in the department, in the College of Construction Design, Construction and Planning, I'm collaborating with construction management. And then outside of the UF, I'm collaborating with Emory University. So how I see these, it's I'm always excited to explore different ways of applying AI to describe urban characteristics, or to describe to add layers of information to talk about the subject. That's my interest of this idea of talk about this multimodal data fusion to describe a subject, or something that has to do with this human-centered AI. How can we actually make a change in how we approach some questions that deal with social issues? And how I get to know them, I contact them, or I look at their work, and I just start a conversation about topics that I'm interested, and then hopefully they are interested as well, and then we start writing grant proposals. That's how we start. So we we start with grant proposals, and then to articles together.
And circling back to one of your earliest comments on, you showed the standard deviation and how, you're maintaining that innovation really happens at the boundaries, at the edges. Are you seeing that happening across the fields you're working in?
I actually don't think that's what's happening. I think we are relying a lot with the normally distributed data. We are making our assumptions from whatever is there, it's the solution. And the problem here is that we cannot control what the data is about. Like, I think most of the floor plans that we have here, that have been produced across the world, are really not good examples, but we're anyway learning from them. So I think it's really important to have this understanding of the distribution of the data, so we know how to go beyond. That's how I see that's how I see AI itself for now. We need to use it. So we need to understand what is the current state of the art, so we don't, or we do.
And using it a bit more as a springboard as opposed to, an absolute answer.
Exactly.
You've given us so much to think about. We do have time for another, if there's a comment or any other question you'd like to raise.
I think I see a comment in the chat.
Okay.
Yeah, so this is from a partner at Emory. So excited for our collaboration here at Emory, University School of Medicine. Yeah, so this project is really close to my heart. I really hope we can do this. And we're collaborating with Lisa, Pat, and Young One on this project specifically.
Hello, can I ask a question?
Absolutely.
Yeah? Okay, I'm a student from construction management, but I have some questions about, I'm very interested about machine learning in the housing shelters, learning that part. And I just searching your paper, I see that. I just want to know, do you have any future research method for how deep is the learning for the housing shelters? I see the in the paper, so do a larger area learnings for the housing shelters. Will you do some in the future for like some single housing shelters, that kind of learning for, what's your future like learning? Do you have any future learning proposals for that areas in the future? Yeah.
On my PhD, I did touch about the design of single shelters.
Mhm.
And my conclusion was that there are so many options there outside, and so many options that are going like from different paths. Like one is going on to prefabrication and automatization, and the other one is going to using existing materials so you don't disrupt the economy. Like for example, this is like two things that come up to my mind. So what I said there is like, we have this data here. Why don't we create a catalog and then characterize each of these solutions as let's say like their characteristics, and then we're able to choose from them. Like to create, first we have to gather this database to have this normally distribution of data, and then we can go beyond. But in this way, we first need to gather the data and then see what it outputs from there, and then how to go beyond.
Okay. Do you have like after you do you want to? I mean, in the future, will you like want to build a database for the like the hurricane shelters? We need to like if you in the future we have like some other areas hurricane shelters research, we can just require the database from you. I mean, you research or you want to do some like criteria for future like research for this, or you just like proposal methods for that. AI learnings could be like doing that. I mean, yeah.
Currently, I'm not actively doing research on shelters. So if I have a database about natural disasters that I can share with you if you're interested in. But of course, if you're interested in crafting this database, and if you need any help, I will be really happy to help you on that.
Okay, fine.
And regarding the architecture of the algorithms, I know they're changing per day, so it's really hard to catch up. So what I would recommend you is to understand like these five I at the beginning I shared with you these 5 research areas to understand what each of them do.
Okay.
And just catch the love, like it's like catching a fish, you know, like you know what you need, just catch the one that you find at the moment, try it out, and if it doesn't work, catch again. Like there won't be one architecture that will solve everything at the moment. Like this is what I have with you.
Yeah, that's my question. Maybe in the future, I maybe have like some interesting parts. I will visit you maybe. Thanks. Okay.
Thank you for your question.
Anything else before we finish up this really insightful time with Karla?
Can I ask a question?
Absolutely.
I wanted to, because especially since this last question was asked, I wanted to ask how fast or how hard is it to keep research relevant within AI, knowing that the field is moving probably faster than any other field has moved? How hard is it to like maintain that relevance throughout?
I will say there are 2 answers to this question. The first is that AI has its own like alma mater house, you know, like computer science. So there it's really, really hard because, as I said, like every single day, one PhD student is graduating, so they have one method that overpassed the previous. So that's really hard and it's very competitive. On the other side, which is where we are now, so we are not computer scientists, we are architects. So how to stay relevant is just to think what architecture can take advantage of AI. So as again, this question about like catching the fish when it comes, since we got trained like 6 years of career plus many other years of experience, we more or less know what we need to do. So we need to empower, like, find this question that makes sense to answer through AI. And that's how you stay relevant. So if you want to mimic someone else's work, you will be always behind. But if you find this question that makes sense for your project or the things you're doing at the time, then you're always staying relevant. It's hard though. Like finding the right question is the hardest part of all. But I think now in academia, it's also really hard to stay relevant because you somehow are not just researching, but you have to manage your time, like how to brand yourself, how to get connected with the right people so they see your work. Like it's more complex than only being relevant, because if your work is relevant now, but nobody sees it, and he sees it like 10 years from now, then it won't be relevant anymore. So it's complicated. I don't know. I don't have an answer.
That's a great observation. And then we also know even in across fields, there are milestone studies, but inquiry is often built on the shoulders of others. And it's a series of studies. The inquiry, the certain projects take legs, and one question leads to another and another. And so you start building a body of work, and then it's informed by collaborations like, Karla was speaking of. And so she's starting off with her lab and, incubating, and then it'll be interesting to see how that there's continuity, but then there's adaptation and change, right?
Mm-hmm. It was really nice to talk to you. I mean, somehow I felt I wanted to show so many things that I was just too fast. So if anyone wants to know more about anything that I shared today with more detail and with more time, I will be really happy to do so.
Thank you so much. And it was wonderful to have you cap off our seminar series, because you were able to share a lot of the work that you've been doing that you wouldn't have had even 6 months ago. Mm-hmm. So yeah, thank you so much for attending, and Karla, all the best, onward and upward.
Thank you.
Okay.